This is all about measurement. The most important part of this is that the definitions that you're going to learn this week and we will go over in class when you return to class are the basis for everything that you're going to be doing this semester. It will set up everything for understanding how each of the tests work, and then also on the backside that when you're analyzing data, if you understand what the basic definitions are, it'll be easier to analyze that data. Just some simple things from that basically our textbook are statistics itself, data. It's a result of measurement. We measure many things. We measure mile times. We measure how much money we make, how much earnings we have. Basically, it's a result of measurement. You measure something. The outcome of that is the data. Statistics itself is how the data is organized, treated, and presented for interpretation and evaluation. And evaluation is the philosophical process of determining the worth of the data. These two, you're going to organize, you're going to treat, and you're going to present data. So it's important that you understand the basics of it to be able to interpret it. In terms of evaluation, the idea is when you're evaluating this data, is it worth anything? You could have numbers that don't mean a thing and not understandable, and it just doesn't work. So in this class, we will spend time organizing it, treating it, and presenting it, and we will be showing the worth of the data by how your outcomes and how much you understand it to be able to tell the story of statistics. The process of measurement, it has 4 steps. Object is to be measured and identified and defined. The standard with which the measured object will be compared and identified and defined. The object is compared with the standard, and the quantitative statement is made to the relationship to the object of the standard. In layman's terms, you're going to be choosing a topic. You're going to decide how you're going to measure it. So if we're talking about something like physical therapy, the knee injury, the different tools that you're going to measure the flexibility of the individual, then you're going to place it into where your mind has it to where they're beginning, and then you're going to do the intervention of the stretching or whatever it is, and then you're going to compare it at the end to see if there's an increase, and then you're going to make a statement. Yes, they improved, or no, they did not improve. And then you'll go back to the beginning and do it again, or it will be a general outcome that is always going to stay that way. It's important to understand what you're testing. In terms of this, we're talking about population versus sample. Think sample small, as the letter S. Sample is small. Population is large. Okay? Think of the census. The census, we have tried to do everybody in the United States. So if we do the census and we touch everybody, we have a representative sample of the entire population. But in research and in statistics, you don't pull from the whole population. It would be almost impossible and very costly to say we're going to take every person that goes into a bank, or every person that runs the mile, or every student in all of America, or every student at Cal State Fullerton or San Diego Christian or USC or any other college, and say we're going to do a study on every person at the school. It's very impossible. So what you're going to do is you're going to take a representative sample of this group, and you're going to do your test, and then you're going to direct the outcome toward a population of that sample group that has the same type of attributes. If you do that, then what you get is you get a solid outcome to show that this sample points toward the population of whatever you're doing. If you look at this slide here, the sample, the population, you'll see that it's a circular motion. Okay, the sample makes conclusions. Okay, and the population is representative of the sample. Types of variables. As we talked about, data is the result of measurement. Well, that measurement comes from understanding the different types of variables that are out there. We start with categorical. Categorical is example of marital status, political party. So marital status, you're either married, single, divorced, widowed. Eye color. They're very defined categories. Brown, blue, green. Okay, political parties, Republican, Democrat. Numerical on the other side has two branches, discrete and continuous. Discrete, think of as the word at the bottom there, counted items, number of children's, defects in an hour, how many years you've been playing football, how many years have you gone to this bank, how many years have you invested money. Okay, on the other side is continuous. It's measured statistics like weight, voltage, temperature. Here's another slide. I try to put in extra slides that pretty much say the same thing because hopefully one of them will click in with you. Data are facts and numbers that are collected, okay, and measured. Types of data. Data that has a name or a category. It's mostly category. What month were you born? Numerical data is data that that is a number of how old you are. Again, going back into continuous variables again, you'll see some other portions of definition here. Okay, one thing on the continuous, it has an infinite number of values. Okay, it can also take any value between two specific values. Okay, so like age, you're either 12 or you're 13. Okay, but it can be anywhere along that line. So it can be 12.1, 12.2, so on and so forth. Discrete variables. A variable's attributes are separate from each other. Think of it this way: male and female separated from each other. Okay, as here it says marital status, gender, nationality. Okay. The other one is the continuous variable is either going to be interval or ratio, and the discrete variable is going to be nominal or ordinal. And we're going to get into those words next.